Here we have AMC math problem. Okay, let's go to the question. Four positive integers A, B, C, and D have a product of 8 factorial and satisfy the three equations over here. We have to find the value of A negative D. Okay, now let me take the first equation over here. That is AB positive, A positive, B equals to 524. Now, to get the factor form of this expression on the left side, let me add 1 to both sides of this equation. Then I'm getting AB positive A positive B positive 1. On the right side, we get 525. When I consider the first two terms over here, we have the common divisor A. We can factor A out. When A is factored out, we get B positive 1 inside the parenthesis. We can factor 1 out from these two terms. Then we get 1 times B positive 1 equals to 525. Now we can factor B positive 1 out from these two terms. When B positive 1 is factored out, we are left with A in the first term, positive 1 in the second term. We get A positive 1 over here equals to 525. Okay, here I got the factor form of the expression on the left side in the first equation over here. Let me do the same thing for the second equation. Okay, now let me take the second equation as it is. It is a BC positive B positive C equals to 146. Now let me add 1 to both sides of the equation. Then we get BC positive B positive C positive 1 equals to 147. We can factor B out from the first two terms, and I'm getting B times C positive 1. And here we can factor 1 out. Then we get 1 times C positive 1 equals to 147. Now we can factor C positive 1 out. Then we get B positive 1 over here equals to 147. Here I got the factor from on the left side of the second equation. Let me do the same thing for the third equation. CD positive C positive D equals to 104. Let me add 1 to both sides of the equation. Okay, here CD positive C positive D positive 1 equals to 105. Let me factor C out from the first two terms. We get C times D positive 1 positive. We can factor 1 out over here. Then we get 1 times D positive 1 equals to 105. Now we can factor D positive 1. Then we get D positive 1 times C positive 1 equals to 105. Okay, now all the three given equations I got factor from for the expressions on the left side. Okay, now let me erase this stuff and continue the problem. Now let's write each of these three numbers as the product of its prime factors. Okay, first let me split up this number 525 into its prime factors. Okay, let me take 525. Okay, since this number ends with the digit 5, we can divide this one by the prime number 5. When I divide this one by 5, I am getting 105. Okay, again it ends with the digit 5. We can divide it by 5. We get 21. And 21 is a multiple of 3. So we can divide this one by the prime number 3. When I divide this one by 3, I'm getting 7. Since 7 is the prime number, we have to stop the process. Okay, now we can write this 525 as 5 times 5 times 3 times 7. Let's do the same thing for 147. Let me write over here. And it's a multiple of 7. So we can divide this one by the prime number 7. When I divide this one by 7, I'm getting 2 and here 1. And it's a multiple of 3. Let's divide this one by 3. Then I'm getting 3 and here 7. That is when I divide 21 by 3, I'm getting 7. We can write this one as 7 times 3 times 7. And here 105. Let's divide this one by 5. Then I'm getting 21 over here. It's a multiple of 3. Let's divide by 3. We get 7. Then we get 5 times 3 times 7. Okay, now let's consider the two expressions we have over here. What do we find in common? We find B positive 1 in common. And now let's get the common stuff over here and here. So we can consider 7 as a common stuff, or even we can consider 3 times 7 as a common stuff. Okay, now let me consider 7 as a common stuff over here. Here we find B positive 1 in common. Here we find 7 in common. Then what is the value of B positive 1? Then it has to be 7. If I consider this 7 as the value of B positive 1, then what is the value of A positive 1? Then the value of A positive 1 has to be 5 times 5 times 3. Okay, now let me write over here. A positive 1 equals to 5 times 5 times 3. When I multiply them, I am getting 75. Okay, here we have taken 7 as the value for B positive 1. Then the value of C positive 1 must be 7 times 3. Okay, let me write over here. C positive 1 equals to 7 times 3. When I consider 7 times 3 as a value for C positive 1, then what is the value of D positive 1? Here we have same 7 times 3 over here, and here we have C positive 1. So when we consider this one as a value for C positive 1, then the value of D positive 1 must be 5. Let me write over here. D positive 1 equals to 5. And here 7 times 3 is 21. Okay, now let's solve for B in this equation. For that, we have to subtract 1 from both sides of the equation. When I do so, I'm getting b equals to 6. Okay, here from this equation, to get the value of a, I have to subtract 1 from this one and this one. Then I'm getting a equals to 74. Now to solve for c in this equation, I have to subtract 1 from this one and this one. Then I'm getting c equals to 20. And to solve for d in this equation, let's subtract 1 from both sides and I'm getting d equals to 4. Okay, here I got the positive integer values for a, b, c and d. And now we have to check the values we got over here for a, b, c and d satisfy the condition we have over here. That is the product of these four positive integers equals to 8 factorial. Okay, now let me check it. That is a times b times c times d equals to 8 factorial. And the value of a is 74 and the value of b is 6 and the value of c is 20 and the value of d is 4. And we know that the value of 8 factorial is, let me check it, that is 40,320. Okay, now let me multiply these 4 values, 74 times 6 times 20 times 4. Then I'm getting 35,520 on the left side. On the right side, already we have 40,320. These two values are not equal. So the values I got for A, B, C and D over here do not satisfy the condition over here. So there is something wrong in the work we have done so far. Okay, when I took value 7 for b positive 1, I considered 7 as the value we find in common in this expression, That's why we considered 7 as a value for b positive 1 over here. And instead of 7, we could have considered this 3 times 7 as a value for b positive 1. Because we find b positive 1 over here, and we find 3 times 7 over here, 3 times 7 over here. Okay, now let's consider this 3 times 7 as a value for b positive 1. Okay, now let me erase the stuff and continue the problem. Okay, here I am taking this 3 times 7 as a value for b positive 1. Then 3 times 7 is 21. When I consider this 3 times 7 as a value for b positive 1, then the value of this a positive 1 must be 5 times 5. Let me write over here. 5 times 5. 5 times 5 is 25. When I take 3 times 7 as a value for b positive 1, then the value of c positive 1 must be 7. Okay, let me write over here. C positive 1 equals to 7. Okay, here we have taken 7 as a value for c positive 1. When the value of c positive 1 is 7, then the value of d positive 1 must be 5 times 3. Let me write it over here. D positive 1 equals to 5 times 3. That is equal to 15. Okay, now let's solve for a, b, c and d over here. Okay, from the first equation, we can solve for b. That is, when I subtract 1 from b positive 1 and 21, I am getting b equals to 20. Okay, from this one, if I solve for a, I am getting a equals to 24. And from this one, I am getting c equals to 6. And from this one, I am getting d equals to 14. Okay, now for these 4 positive integer values, let's verify the condition we have over here. Okay, now let's multiply the values of a, b, c and d. That is 20 for the value of a, the value of b is 20, the value of c is 6 and the value of d is 14. On the right side, we have 8 factorial. That is a product of the 4 positive integers equals to 8 factorial. Okay, when I multiply these 4 values, I am getting 40,320. And already we have the value of 8 factorial, that is 40,320. Now we have the same value on both sides of this equation. So the positive integer values we got for a, b, c and d over here satisfy the condition given here. So now we can consider this 24 value for a and 14 value for d. So to get the value of this expression a negative d, that is a negative d equals to the value of a is 24, negative the value of d is 14, 24 negative 14 equals to 10. Okay, here I got the value of a negative d, it is 10. We find this 10 in answer choice D. The correct answer choice for this question is D.